So today we're going to go ahead and deal with our lesson 1.3. Today is day 1. Tomorrow we're going to get a little further into lesson 1.3, which is where dun 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 the proofs will come in. But for today, as you can see, this bell work was a ton of verbiage and copying. As I stated, I will be looking for these items to be properly listed in your bell work when I do notebook checks, which are coming soon to a theater near you. As mentioned, it'll be about once a week. That being said, I'd like us to look at example 1 really quick. Example 1 really quick. Now, a lot of us, including myself, were never, we don't love proofs, I get that. But I've found that over the years, if I am slow and if I read and reread things, I am usually able to determine the proper response. Okay, so please realize that we're going to be doing most of the proof work initially together, and then I'm going to be challenging you on your own so that you can own it. What's the property? So I'm going to do these with you. Now sometimes it's going to come right out of the book, which is the exact thing I'm doing today. Sometimes it'll be my own examples, and if it's my own examples, I'll usually put a little star so that you recognize you're not going to find it in your book. If x plus 4 is 3, that kind of seems crazy. Okay, regardless of how weird this looks, so negative, I'm sorry, what number would we put? Negative 1 added to 4 is 3. We don't care about that. All they're saying is, if this is true, then this must be true. So, for me, what changed? Well, I've got this statement. Then they doubled the first statement, which then doubled what it equals. Doubling is multiplying, okay? So if I double this, I get an answer that is doubled. If you look at your properties of equality, this, my friends, is a multiplicative, I know, or multiplication property, and they don't have it filled in, but it's of equality. All of this stuff right here in example 1 is all stuff that is gleaned from the properties of equality found above, okay? So this all here is going to be props of equality. It's not always going to look that way, but just so that you kind of recognize that. Continuing on with B. So B, yep, you're already seeing it. So Z is equal to A plus 2, if this is true, and A plus 2 equals 3, then Z has to equal 3. Okay? So, they've stated this, and they've told me that the actual result is this. So notice, A plus 2 equals Z, and A plus 2 equals 3. That is telling me that these two items equal each other. So given these two equations, I am able to say that I can translate, in my mind I like to use that as a reminder, that I can translate the fact that Z is the same as 3. This property is the transitive property of equality. I took these two statements, realized that these two things are the same thing, they both equal something, therefore these two things must equal one another. The final property of equality that we're going to chew on here a little bit is the symmetric property of equality. So let me talk through this one with you. If x is equal to the sum of y and z, then y plus z equals x. Okay, this is equal to that. So this is a mirror image of that. Anything that is a mirror image is the symmetric property of equality. Okay? That is the symmetric property of equality. Like you could say A equals B plus C, therefore B plus C must equal A. Same. Okay? Same scenario. Now, the next page in the blue, it says field properties of real numbers. So these are a chunk of properties that all over the place are used. They're not all one thing. We have different things we're going to look at. And I promise you, you're going to be either flipping back to these pages or flipping into your bell work on a regular basis, at least for a little while. All right? I really don't expect you to memorize the terminology very well. It is my plan that when you are quizzed or tested on these items, I'm going to give you a little hint sheet. Okay, and I'm going to leave it at that, or I'll blast a little hint sheet up there. So example 1 we're done with. Let's go ahead and go into example 2 real quick. Everybody's wrists tired? I know. Simplify. Okay, you're thinking this is coming out of left field. We just did this. We already know how to do this. Well, what this is simplifying, but you're going to use the properties you already know. You may not even be able to name them to help make these problems easier. Okay? So take example A. You already do this naturally. Don't get scared of the properties business. You guys are already doing this. If you don't have a calculator in your hand, you are already probably mentally doing what I am about to show you that you do because of a given property. All right? So right now I have this set up. I know that 7 and 13 give me something I can add in my head, whereas 7 plus 11 plus 13 is just too hard for me. I'm not smart enough. Okay? I also know that 11 plus 19 gives me something that I can add in my head. Anything that can give you something ending in a 0 is always going to be easier to do. This maneuvering, what we just did, is called the commutative property. It's not asking you that, but I am telling you what it is because I want you to be aware of it. This is the commutative property of addition, which states that moving within an addition problem is acceptable. It gives you the same answer. So in my mind, I have done this and this, okay, which gave me 20 and 30, which is still 50. If you guys plug this data into your calculator as it sits, you'll still get the same answer, but in real life, you don't always have your calculator, or at least it's not always handy. So I need you to be able to realize you can move addition problems around to suit yourself. Same goes for multiplication. I'm sorry, let me do B here. I don't want to move on yet. Same goes for letter B. 26 plus 8y plus 14. Okay, this is what they've started with. We're going to commute again. Which items would you say would be best slammed together? Oh man, your numbers, beautiful. I see 26 and 14. Thank you. And anytime I ask like that, please shout it out. Otherwise I fall asleep up here. 26 and 14 is going to give you 40. Your answer can be written like that. You can also, if you like, give me 8y plus 40. That's usually how it's written algebraically anyway, variable and then number. I will not mark you wrong regardless. If you give me this or this, you're right. All right? Finally is example 3, and that's where we're quitting for today. Proofs are tomorrow. Example 3. Can I turn my notes, folks? Okay, if anybody needs a little more time, I'll give you another 3.5 seconds. That's it. Moving on to example 3. Last one for today. Hooray. Simplify. Again, you guys already know how to simplify, but the purpose of today is to help you to recognize that you can maneuver things or use the rules, also known as properties, to make your life easier. All right, this is a multiplication problem, okay? That being said, it is going to be much more convenient for you to first find all your numbers and get them together. And I'm just going to write it like that. I'll get that in there first, so don't worry about it. Which is 16 times 20. Would y'all agree with me on that? In your head, y'all should be able to tell me that that's 320 because it's 16 times 2 add a 0. Okay, we've already dealt with our numeric adventure. Now we're left with the product of x, y, y, and z, z, z.
Would Grant, Percy, and Kate please go meet Mrs. Graham in the gym? Thank you.
Give me 3.5 seconds and I'll kick you guys out of here. The product of x, y, y, and z, z, z is x, y, y, and z cubed. We used the moving, which is the commutative property of multiplication to make that happen. Moving things within a multiplication problem is always acceptable. It always, always, always will produce the same result. Just like when you learned your facts, 6 times 2 is the same as 2 times 6. All right? No different. We did the same thing here in a variable phrase. Okay, my band, you guys, my worship team. Your homework, of course, is posted. I'm going to stop.